Okay, swing over here, zoom in a smidge perhaps. Okay, crank it up. Duct tape and your elasticity, I love you. So you fire up the program, first thing it asks you for is confidence. You're going to pick, unless the book tells you otherwise, which it might, you're going to pick 95%. Doesn't matter if you put it in as 0.95 or 95, I wrote the program to accept either. The margin of error though, and this is something the video will explain very well on tomorrow, the margin of error you're selecting is the maximum allowable margin of error that you will accept. Hey, Rich. The maximum allowable acceptable margin of error. So you have to decide before you start your study, okay, how off am I going to allow myself to be? In that study right there, this fictitious study I created, how off were we from our center? I.e., what was our margin of error? 2.5%. That might be the most you want to be off. That might be the most you want to be off. If that's the most you want to be off, you want to put 2.5% in right here. As a decimal, that would be, thank you Eric, 0.025. This is easy to screw up when you're entering it in very quickly. And I make you put it in as a decimal because as margins of error get smaller, people screw up the decimals even worse. Or screw up the non-decimals even worse, I've noticed. And it becomes a coding nightmare. So, enter it as a decimal. So if you only want 2.5% error maximum 2.5% error, you better go get 1,537 people at least. If you get more, what will happen? If you get more than 1,537 error, what's going to happen in that interval? It's going to shrink. Remember the formula, just visualize it in your head. The formula for the margin of error. When Eric says the interval is going to shrink, that implies the margin of error is decreasing. Visualize the formula for margin of error in your head. I'm never going to ask you to crunch it manually. But where is the n variable in that formula? In the denominator, Kayla. And if the denominator gets larger, which the sample size increasing would do, if we increase confidence, what is going to happen to the width of our interval? If we increase confidence, I vote for bigger, and a nod for bigger, and 3 nods for bigger. That's 2, actually. There we go. It's going to get larger. How come? How come? Either conversationally or mathematically, how come? What do you think? Please!
The bigger your parameter, the more likely you are to have a...
Oh, good. If you increase confidence, you have to make the intervals wider, to go back to what Mimi said earlier. Because if I'm at 99% confidence, now the parameter hasn't moved. The parameter hasn't moved at all. It's still out there floating around in the world. We're trying to catch it. But the only way to catch it more is to make the intervals wider, so the ones that used to miss it now catch it. Good. I wasn't even thinking that. That's fantastic, Jack. Good. I was thinking purely mathematically. The formula for the margin of error has that z out front. The z multiply that critical value I was calling it in class on whatever that class was, Tuesday. And since that's technically the numerator of the fraction, and you make that bigger by increasing numbers of standard errors, it has to get wider. But your definition, your explanation is way better, dude. In 95, no, it is, because think about it logically. In the 95% of the ones that used to catch it, we have to increase some of those to pick up the parameter that they missed. So it's basically the ones that are too skewed left or right. They have to be adjusted by making them wider. Your way is way better to explain it. Yeah, it's very good. Thanks, sir. Good enough? Now, I want to emphasize this, and the video will answer it more tomorrow. That is the maximum margin of error you have to accept. It might come in at less than that. And the video, I'm not going to explain it now because, let's face it, it's 8:45. You don't want to hear it anyway. It's a purely mathematical reason. It involves some Algebra 2 or some calculus. And I'll put it in the video without using calculus. I'll use some Algebra 2 to explain it. But that is the maximum. Chances are it's going to come in at less than 2.5%. And I'll explain that mathematically in the video that I record for you guys. Yeah? Decent? Cool. Okay. How we feeling? All right? Good? Everybody happy? Everybody content? Happy, it's a math class. Let's be realistic. Exactly, right? Let's be realistic. It's a math class. All right. How about quizzes? Decent? Did anybody give a shot to the one I made one due today, or if you want on Tuesday? Did anybody give it a shot today? Was it okay? Was it, okay, good. You had enough. But I wanted to make sure we had enough chance to pick up a 20-minute discussion or so to make sure that any loose ends got tied up. It sounds like you guys have the loose ends all tied up nicely and neatly. So, cool. Any other questions? This is not going away, mind you. It's just I want to change gears to see how we deal with other kinds of data. And then I want to hopefully by the end of the day bring it all together into one big picture, and then next week we kind of take the next step down the inferential path. Solid? Puberty, man. I've been practicing my butterfly in the pool. And any guys swimmers in here? Got a couple of swimmers. Yeah, you guys swim butterfly? Yes, no. I don't do it well at all. I started learning about a year ago. I drink an awful lot of juniper every Monday, Wednesday, and Friday, and I think it's starting to bleach my vocal cords out. It's pretty horrendous. Butterfly, it's one of those things though. Have you ever tried butterfly? You guys have tried it, obviously. Anybody else ever tried the stroke butterfly? It's like just try, don't die. It's what I'm thinking the whole time. Just don't die. Breathe. Don't die. Breathe. And every once in a while, it's a total SOB because every once in a while I get it perfectly. And I just undulate through the water like a dolphin. I'm like, I'm a dolphin. I'm a total dolphin. And then I drink more water, and I stop.
I'm not a dolphin.
I'm not a dolphin. I am a 40-year-old dude.
Flailing through the water.
But I think it's, you hear that? I think it's bleaching my vocal. Anyway, more fun for you guys. All right. I think we actually want to be right where we are right there.